Welcome to Fun Python Projects. In this video, our focus shifts to how to make a password generator. Sometimes, uh, making up a password can be such a hassle. It can be such a difficult thing to do. But with you can have your own customized password generator where you can, you can decide the length of the password and you can have as many passwords as possible based on what I'll be doing here. So the password generator uses secrets. Secrets are cryptographically strong, and it lets you pick the length of the password, how many passwords you want, and which character sets to include, while guaranteeing at least one character from each from each selected set. Sometimes when you're filling a form, they tell you you must have a number, you must have a letter, you must have a special character like a percent sign, and things like that. So this is exactly how you can do that on your own. How it works is that it uses secrets for cryptographical secure randomness. All right, it's random, but then it is still secure. It ensures each chosen class, maybe lower or upper or lowercase letters, uppercase letters, digits or symbols, is represented at least once. It avoids visually ambiguous character if you want, like 0 and 0, L and 1, all these things that can confuse you. So it will avoid it. Then it shuffles the results to remove positional bias, and it prints entropy and a rough strength label. Okay? So look at this now. You have a password generator with autosave for Jupyter Notebook. So maybe you are like a database administrator, and then you're saddled with the responsibility of creating passwords for people like that. So in that case, you can do several passwords at once, and then for the sake of your use later, the password will be saved in a CSV file so that you can, then maybe send emails or do whatever you need to do to get the passwords across to the people that are in need of it. Okay. So here we are, all the libraries we use are inbuilt libraries in Python, like secret, string, math, pandas, which we import as PD. So we need the secrets library, the string library, the math library, and pandas library. We usually import pandas as PD. Then from datetime, we import datetime. From ipython.display, we import display and HTML, and we import OS, that's the operating system. So here, imagine you want 100 passwords. That's the number of passwords you want. And the length of each password should be like 25 letters. And of course, the idea of password is that no password should look like the other one for the sake of security, right? So imagine you are generating 100 passwords with would have 25 characters each, like that. Then you also want to exclude ambiguous things. Exclude ambiguous true. That means remove characters like zero, the zero and the two zeros. One has a strike, the other one doesn't have. The L and one that look a bit alike that can be confusing. Then you want to include symbols true, include symbols like the uh, @ sign, the hashtag, dollar sign, and percent and so on. And then that takes us to the core logic of the whole thing. So for the core logic now, you have an input set, okay? You have I, L, 1. So all these ones, they're ambiguous, so you don't want them. S and 5, B and 8. So 1 and L. So the IL1, 00, O, S, 5B, 8, G6, Z to Q9. Things that can look like themselves. So they are ambiguous. So you want to exclude all of those, right? Then the default symbols, now you have the symbols, the exclamation, at, uh, hash, and all of them like that. Then you define the build character sets, which will include lower, true, include upper, also true. So you have uppercase, lowercase. That's what guarantees a safe password. So to have a safe password, you need a mixture of all of these things. Something that'll be difficult to guess. That is why it is advisable you don't use your date of birth, your age, and things like that as password that somebody can easily guess. Then include digits true, include symbols true, exclude ambiguous true. Then look at the sets now. If include lower, S is now set, string, AS, ASCII lowercase. So you have all of that in lowercase. Then you can then append it and join. So then you have all the S minus ambiguous. You don't want anything ambiguous. Then if exclude ambiguous, else do all of this in lowercase. Then you can also include upper. So upper cases are allowed and ambiguous are also excluded. You can include digits like that, apart from 0 and 1. So, and even 9, I think, or and 5, 8, and 6, I think. So you can include all these digits. So, of course, you can have some of this, but you don't want to, you cannot have two of them or something, I think. So, include digits. So, you can also include the symbols, all the symbols like that. You can add them and remove all the ambiguous ones. Then default generate password, talking about length and character sets. If not character sets, so if whatever you're doing is not does not belong to all the character sets with lower upper digits and symbols and excluding ambiguous, then it's to raise the value error, no character set selected. If the length is less than the length or character set, to raise value error, length too short. So if you have too short length for character set required classes. Then you have RNG, secret of system random, PW, RNG.choice CS for CS in character sets. Then all characters you join together, no space. Then PW plus, so you keep updating like that. RNG.shuffle PW, then you return the join PW. Then you have you define a function called entropy bit now. So length character sets. So you have the union. So you map all the sets and character sets together, and then you return 0.0. If not union, else length is math log 2 length of the union. Then you generate the password. So you have character sets will now be equal to build character set, true, include symbols, exclude ambiguous, bits, employ bits, length and character set. Then the password will now be generated. So generate password of length and character set for everything in the count, right? Then this last part is what helps you to save the password because there are many. Instead of copying and pasting one after the other, you can just have them saved to a CSV document. So you have a data frame, pd.data frame, passwords, then timestamp. You have the timestamp in year, month, and date, in hours, minutes, and seconds. Then save to the default content directory for easy download. So you have CSV path equals F content/passwords. So you have a CSV file called passwords underscore the time it is generated .csv. Then it's now you now write the data frame to CSV. So you have CSV underscore path index is false. Then you can display the outputs also. So you display output and also save to CSV file. Then you print generated the number of passwords you want. Like in this case, I want 100 and the length is 25 characters each. Then you can print the entropy bits. So bits per second, and then you save to the CSV file. So having done all of this, you can just run this. Okay, we run this now, and then we have the results after in a bit, I think. Good, so we have it. So you can see the display because it's 100 passwords as usual. We know Panda, that's what Pandas does. It shows the top 5 and the last 5. So you can see all the passwords, very foolproof passwords. Because I want 25 characters, that might be too long, but I mean, if you want 10, you can do 10 too, right? Anything you want, you can do for sure. So feel free to do all of that like that. So I have 100 passwords with 24 characters each. So what about the CSV file now? The CSV file with passwords underscore 2025 1009. So this shows you when it was created. So I come here and click, so you can see the CSV file. So if you double click on this, so you see the CSV file containing all the 100 entries. So this one is 10 per page now. Okay, yeah, this 10 per page. Can I do 100 per page? Is it possible? Yeah, I can do all the 100. So I can see all the 100 passwords at once. So you see that? So you can generate passwords like that. So this can be very useful if you manage a database and you're saddled with the responsibility of creating passwords for people, right? So the features of this password generator include the following. So you use secrets for cryptographically secure randomness and ensures at least one of each character type, avoids ambiguous characters if desired, displays result directly in the notebook, and saves automatically as a CSV, and it is timestamped to show you when it was created. So this one shows that the document password underscore 2025, the 9th of October, and the time 5:06:32, maybe system time now. So, and then of course you can also always have this here. You can download this, okay, like that, and then you can access that in your downloads. Okay, we come to downloads, right? So you can see this is what the list created. Of course, passwords are very sensitive, so you want to be careful the how you handle them. You want to make sure that they don't get leaked, that unauthorized people don't get to see them. So you can see all the passwords now. 1,100 passwords. Each one has 25 characters like that. So that's what our password generator is capable of. So you can see this one has practical application like that, you know. So with all of this done, I can say I've come to the end of this video talking about making a password generator. Okay. Let me know how helpful this is for you. And if there's something else you'd like me to try out, feel very free to let me know. Okay. If you have subscribed already, I thank you. If you have not subscribed, why not go ahead and subscribe right away and hit the notification bell so you can always get alerted each time a new video is released. Having done that, you can take it a step further and become a member of the channel. All you just need to do is click on join. And once you click on join, you see 3 levels of membership you can be part of. And that gives you some special privileges. Okay. Um, uh, with that done, of course, ultimately, don't forget to comment, like, and share so that more people can have access to the great content I have going on here. All right. Till I come your way again, keep doing Python right. Bye.